Newton's laws of motion, lesson 2. Can we recall Newton's laws of motion? Hopefully we still can. First law, objects either stay at rest or move with constant velocity unless acted upon by a force. The second law, force is proportional to mass multiplied by acceleration. We say F equals ma. The third law, for every force there is an equal force in the opposite direction. So we're on the second lesson of this topic. We'll look at Newton's third law in more detail. We'll look at what inertial mass means and some applications of all three of Newton's laws. So, our spec reference is still the same as part. Know and apply the three laws of motion in different situations, including F equals ma, where mass is constant. So we should be able to state Newton's third law and describe what it means, and be able to identify force pairs, explain why weight is different to mass, and why you experience less support as an ascending lift stops. So, you'll have seen a force diagram like this one, with a book on a table. So we've got two forces that we can label. The weight acting downwards, the green arrow, so we would call it, if we're writing it out in full, weight is the gravitational force of the Earth on the book. So the Earth causes the force is on the book, and it is a gravitational force. Opposite to that is a reaction force of the table on the book. Because the book's weight pushes down on the table pushes back on the book. So we'll look at that. It says reaction force, that is the type of force. If we remove the book, that force would no longer be there. It is of the table causes the force, and it is on the book. So we've got a force diagram of the forces on the book. Newton's third law states, we can put it more complicatedly, and say that if an object A exerts a force on another object B, then object B exerts an equal and opposite force on object A. Or we could say it how we just say it on the previous slide, about how forces occur in pairs that are equal and opposite. This law tells us that forces occur in interaction pairs. It applies to all forces in all situations, but you often hear it phrased and applied either incorrectly or with a bit of confusion. So I mentioned on the previous lesson that sometimes you hear it referred to as for every action there's an equal and opposite reaction, but we're on about forces, so we want to say force in our definition. So I would say we want to talk about how forces occur in pairs that are equal in size but opposite in direction. So we need to be careful with how we label the forces. And if we're careful about that, the interaction pairs are obvious, but these two are not an interaction pair. The reason for this is they are different types of forces and are acting on the same object. So reading the statement that I just put, the first paragraph, if object A exerts a force on object B exerts a force on object A. So the first one of the pair is on object B, the second one is on object A. They are not both on the same object, whereas the red and the green arrow are all both on the book. So, on the second picture, we can see what the pair to each of those forces is. So the pair to the first arrow, the weight of the book, the gravitational force of the Earth on the book, the pair to that has got to be a gravitational force. So it would be the gravitational force of the book on the Earth, the weight of the Earth. That sounds a bit strange, doesn't it? But when we look at gravitation next year, we will see that gravitation is both masses attract each other, and they attract each other by the same amount. It is the same force of the book on the Earth as the Earth on the book. The difference is the Earth's a lot bigger, so I don't really notice it. The red arrows shows the reaction forces. The table pushes on the book, but the book pushes on the table. Well, that makes sense, doesn't it? Because neither is like quicksand, it doesn't go through each other. So they both need to have the force of Well, what's causing the reaction force? It's the outer shell electrons in the book and the outer shell electrons in the table get close together and repel each other. So what are we saying? We're saying that it's a familiar example, but the two forces we normally label that are equal and opposite are not the pair. They are not an interaction pair. The interaction pair is by swapping over what the force is acting on and what is causing the force. So each pair of coloured arrows match as an interaction pair. And it should be quite easy as to how to get it. If we write it out like I have done there, reaction force of table on book, we swap over the last two things. We say reaction force of book on table. Or if we're looking at the weight, the gravitational force of the Earth on the book is matched by the gravitational force of the book on the Earth.